Dear students, I am here with the second part of the topic, antenna. Principle of antenna. Antenna is a metallic device which converts electromagnetic radiation in space into electrical signal or vice versa. The shape and the size of the antenna determine how much energy is radiated. Antenna is a transducer which converts one form of radiation into electrical signal. The basic functionality of antenna is shown in figure. The same antenna can be used in both transmitting and receiving station. This property is known as reciprocity. When transmitting antenna converts electrical signal into electromagnetic waves and radiates them. When receiving antenna converts electromagnetic waves into electrical signal. The functionality of an antenna depends upon the radiation mechanism of a transmission line. The information signal is to be transmitted is given to the transmitter after processing, then given to the transmitter antenna. This antenna converts electrical signal into electromagnetic signal in space and radiates them. The electromagnetic signal is then picked up from the space by the receiver antenna. The receiving antenna converts electromagnetic signal to electrical signal. The antenna is required in the field of wireless communication. Also helps the communication in remote area like valleys, mountains, etc. Working principle of antenna. The figure explains transmitter and receiver antenna. The receiver signal is radiated this signal through the space to the receiver. The working principle of antenna is that it converts electrical current, that means carried along by the metallic conductors, into electromagnetic radiation or vice versa. That means it converts electromagnetic waves into electrical signal. Antenna can be used both to transmit and receive electromagnetic waves. After radio frequency signal has been generated in a transmitter, it must be used to radiate this signal through the space to a receiver. The transmitter signal is sent into the space by the transmitter antenna. The radio frequency signal is then picked up from the space by the receiver antenna. The radio frequency energy is transmitted into the space in the form of electromagnetic waves. As the traveling electromagnetic field arrives at the receiver antenna, radio frequency voltage is induced into the antenna and then passed into the receiver and converted back to the transmitter radio frequency information. The design of antenna system is very important in transmitting a station. The antenna must be able to radiate efficiently so the power supplied by the transmitter is not wasted. The dimensions of transmitter antenna are determined by the transmitting frequency. The dimension of the receiver antenna are not critical for low frequency. If the radio frequency signal increases, the design of the receiver antenna is critical. What is the principle of radiation? The functioning of an antenna depends upon the radiation mechanism. An accelerating charge radiates the electromagnetic energy. A stationary charge will create an electric field around it. If the charge is moving, a magnetic field is also created. Also, by changing the magnetic field, an electric field is created. The mutual interaction of time varying electric and magnetic field produces electromagnetic field. The time varying electric field and magnetic field that are perpendicular to each other. The figure is shown in right side, and it produces electromagnetic waves that propagates at the speed of light. The radial electric field around an electron is shown in left side, The center of point is electron charge and the other lines are electric field. The electric field induced due to the stationary charge is given by ER equal to 1 by 4 pi epsilon 0 into E by R square, where ER is the radial component of the electric field and 1 by 4 pi epsilon 0 is the proportionality constant, E is the charge of electron, R is the radial distance from the electron, epsilon 0 is the permittivity of free space. From the equation, the few points were studied. Electric field depends on the charge of electron and radial distance from the electron. And second one is electric field is inversely proportional to R, which is the distance between accelerating charge. Electric field is tangential to the direction of motion of electron. Electromagnetic waves travels at the speed of light. Electric field is directly proportional to charge of electron. In order for electron to radiate electromagnetic radiation, it needs to be accelerated. The following points were concluded for radiation mechanism. First one is to create the radiation, there must be time varying current or accelerating charge. If a charge is not moving, current is not created. There is no radiation. If a charge is moving with uniform velocity, there is no radiation if the transmission line is straight line. There is radiation if the transmission line is curved, bent, discontinuous and terminated. The commonly used antenna is dish antenna, also known as parabolic reflector antenna. The main advantages are it has high directivity. This type of antennas can be used in TV broadcasting, satellite communication and radar. The shape is disc. It consists of feed antenna and parabolic reflector. Here, the transmitter signal is A1, A2 and B1. B2 to the space. The receiving signal A2, A1, F and B2, B1 and F. The operating principle of parabolic antenna is that a point source of radio wave at the focus point F will be reflected into the plane beam along the axis of reflector. Conversely, an incoming plane wave parallel to the axis will be focused at the point at the focal point. When electromagnetic wave hits the shape of parabola, the wave gets reflected onto the feed point. It receives the signal to convert it into electrical signal and forwarded it to receiver circuitry. What is the working of parabolic antenna? In transmitting antenna, radio frequency signal from the transmitter is supplied to the feed antenna. This feed antenna is placed at the focus of paraboloid. Feed antenna converts it into electromagnetic waves. The electromagnetic waves incident on the reflector are reflected back into the parallel beam and then to the space. The receiving antenna gets the signal to the reflector and back to the feed. The receiving antenna converts electromagnetic signal to the electrical signal.